Well, thanks for joining me today for our discussion on lubricity improvers and lubricity treatment options for diesel fuel. I am Eric Bjornstedt. I am with Bel Performance, and I am the Technical Information Director. And what we want to talk about today is we want to talk about this issue of fuel lubricity. We want to talk about lubricity improvers. We want to talk about how they work. And we want to talk about some of the rules and regulations and standards that have created a scenario where these lubricity improvers are now needed in fuel. And then we want to wrap up with a discussion of just a consideration of some options available from Bel Performance that help fuel users to meet those requirements. So first off, we need to kind of define some terms here in order to help us better understand this whole concept of lubricity and lubricity improvers and the like. So first thing we have to kind of define is, what are we talking about with this term lubricity? Lubricity is defined as, it's a characteristic that is defined as the ability of a fluid to minimize friction between a couple of moving surfaces. It's also the ability of a fluid to minimize damage to those surfaces that are moving and rubbing together. And generally speaking, there are parts in diesel engine systems, whether it's fuel injectors, whether it's fuel pumps, there are parts that to which this lubricity concept is very, very important, because those parts, they work very hard, they work under very tight tolerances, they generate a lot of heat, they move a lot, and those parts, without any kind of lubrication protection, those parts will wear out a lot more quickly than they should. And given that lubricating oil doesn't go to places like fuel injectors, it means they have to rely on the lubrication from the fuel that's moving through them in order not to burn out too quickly. So lubricity improvers are things that are added to the fuel in order to increase the lubricity rating of that fuel. And then they do that by, when they're in fuel and they come in contact with these moving parts, well, they help form boundary lubrication protection. They form a protective layer on the metal surfaces. Now, when we said that lubricity is a characteristic of liquid, and we should point out that while lubricity is generally associated with things like fuel and engine oil and things like that, actually any fluid that you want to name has a lubricity rating. So it's not just something that is unique to actual lubricants. Every fluid has a lubricity rating. However, as you can probably guess, the lubricity rating of hypochloric acid or bleach or water is not nearly going to be as high as the lubricity rating for a base lubricating oil, or even something like graphite, which has a really, really high lubricity rating. So, as we said, fuel injectors and fuel pumps, they rely on the lubricity protection from the fuel to prevent damage and to extend their working lives. Now, fuels have changed dramatically over the last 20 to 30 years, and this has created a market and a need for lubricity improvers. Around 2006, ultra-low sulfur diesel fuels were mandated to be created. They removed sulfur in order to help the environment, which is a great thing. That is a very important goal. The downside was that because of the extensive hydro treatment, the extensive processing at the refinery to get that sulfur out, it created a fuel that simply does not have the ability to meet the ASTM lubricity requirements. And so in order to solve that problem, they have to have assistance, essentially, and that's where the lubricity improvers come in. Sulfur is removed through this hydro treating process, and sulfur helped you. From a traditional standpoint, sulfur was associated with providing some lubricity benefit, but it wasn't just the removal of the sulfur that lowered that lubricity rating. Through the hydrotreating process, not only was the sulfur removed, but they also removed and destroyed naturally occurring polar molecules that used to contribute to the lubricity protection. So, bottom line is that the ultra-low sulfur diesel fuels, just by themselves, do not provide enough lubricity protection to meet any kind of legal limit. And also keep in mind that lubricity improvers have been used in low viscosity fuels to help them meet low temperature handling specs and to help them reduce emissions. But for our purposes, that's not really what we're concerned with. That's just a kind of a minor FYI. What we're concerned with is making sure that the ultra-low sulfur diesel fuels that virtually everybody has to use nowadays are not going to cause problems. Now, lubricity, this concept of lubricity additization and lubricity additives is not something that just suddenly appeared in 2006. No, there's got a little bit more history than that. Back in the 60s and the 70s, it was mainly confined to the industrial area. You had gas turbines, which were using diesel fuel to produce power, and there were some fuel lubricity problems that were contributing to their failure, and that is an extremely expensive failure when you have a gas turbine. It was also very concerning for the military. So the military thought that the solution to this was to use a corrosion inhibitor additive. So that's what the military used for a number of decades. 1990 is when this problem started rearing its head on a level that's closer to where we are, because Scandinavia, I'm not sure if it was Finland or if it was Norway or Sweden, or it may have been all of them, but they started, they've always been a little bit ahead of the United States when it comes to things like this. So Scandinavia started doing fuel desulfurization down in around 1990. And that was a couple years ahead of the United States pace. But what they found was that when they took the sulfur out, that it started causing vehicle failures. And that's probably one of the things that the United States looked at when we started considering it a couple years later. And basically we had to learn from Scandinavia's failures in this respect. So in the early 90s, we tried to stay ahead of the game here in the U.S. by producing lubricity improver packages and putting them into the diesel fuel, because in the early 90s was when we really wanted to start reducing the sulfur content from 5,000 down to 500. And of course, they learned from Scandinavia that there were going to be problems, so we started producing lubricity improvers to try and head that off. So, looking a little closer at the Scandinavian experience in the early 90s, like we said, they were reducing fuel sulfur content from 5,000 down to less than 500. It's a 90% reduction or more, and this was causing vehicle failure. So the initial solution that they came up with were these things called dimer acids. So they started making these dimer acids, and for the meantime, they found that the fuel pump wear problems that they were having were alleviated. But what they started finding was that the dimer acid lubricity agents were not a perfect solution. There were problems that came up, side effects, shall we say. Side effects that came along with use of those. First of all, they had to use, relative to today, they had to use fairly high treat rates of these things. And that was causing certain kinds of deposits in places that they didn't want them to go. Deposits caused mainly because of interactions with lubricants. Diesel engines tend to have, diesel engines tend to have some unwanted interactions between lubricants and combustion chambers and lubricants and fuel. It's always been that way. You want to minimize that, but it does tend to happen. And what they found was these dimer acids were interacting with the lubricants, and causing deposits. So that caused the industry to develop some alternative solutions for use as lubricity agents, and those were non-acidic technologies, esters, and amides. Like we said, dimer acids were the first ones that were approved. They were approved by the military, and they tended to perform well. They were approved for use in pipelines, which is always important. They had good low temperature operability, but like we said, they had downstream lubricant interactions. So in response to this, they started producing these things called amides and low acid amides, regular acids, amides, and low acid amides. They still found, however, that there were some lube interaction problems. The performance of them wasn't quite as, not quite as consistent as they wanted, and they tended to have undesirable caustic interactions and interactions with water that they came across. So it doesn't sound like the best solution, but and in addition to that, there was sulfur involved with those, so they did not meet the 15 part per million sulfur cap. So, this is a problem. Not really the most ideal solution. In fact, it seems like it's almost causing more problems than the dimer acids did. So they said, okay, well, let's look at non-synthetic esters. So they started producing those. And non-synthetic esters had, they were a significant step up from that. They didn't have any lube oil interactions. They performed really well. They, in terms of their low temperature solubility, that was kind of a downside, was that if you had a low aromatic fuel, which a lot of these diesel fuels were, the low aromatic, the hydro-treating of those tended to remove some of the aromatics. So the diesel fuel that they were getting with ultra-low sulfur diesel had a lower aromatic content than the low sulfur and the high sulfur diesels used to be. Well, that creates a little bit of an issue, because when they started putting these non-synthetic ester lubricity agents into those fuels, they were finding that they were having solubility issues. And the sulfur issue still wasn't quite solved. They weren't 100% sure if they were going to cause the fuels not to fail the sulfur cap. And really, I should backtrack on that. It wasn't necessarily making the fuel fail. It was whether the neat 100% concentration additive itself met the 15 ppm cap. So we're going into the those are some options that they were developing in the early 90s. So as we move into the mid-90s and low sulfur diesel is becoming, the dominant one, dominant option in the marketplace, they've really created an expanded market for these lubricity improvers. So the lubricity improver use really took off. And there was these esters that tended to dominate the use. Now, esters started showing that they had some issues. The problem, though, it wasn't, lube oil interaction, or it wasn't cold weather solubility. It was cost. Cost was a lot of these. The fuel has always been a very cost-sensitive commodity. They operate off of hundredths of a penny. These points that translate to hundredths of a penny. And these points matter. Well, it was becoming too expensive to treat these fuels. They had to figure out a way to get the costs down. And so what they did was they started producing these things called monoacids. And monoacids is where we are today. Monoacid lubricity solutions. They don't really interact with lube oil to the extent that dimer acids did. They're generally speaking, they're better on the low temperature, and that's an important distinction, because in the beginning, when they introduced these monoacids, they started finding, here we go again. They had these low temperature operability problems. When you put them into the fuel, that fuel, goes, you're using the fuel up in Michigan, it gets really cold. They were finding that they were getting, cold weather precipitate. It was causing deposits dropping out of the fuel. Well, they went back to the lab and they reformulated some of these, and they were able to come up with versions that didn't behave this way, and that solved a major issue for the market. They also solved the issue of sulfur because, by and large, they don't really have much sulfur content. So they were able to help stay in line with the sulfur cap restrictions as well. So, all in all, monoacids seem like a pretty good lubricity solution. Well, then other companies came along and they said, well, let's go a step further. Let's start creating some fully synthetic ester stuff. And synthetic esters tend to be pretty good. They don't interact adversely with anything. They're good at low temperatures. They stay soluble in fuel. They perform really well. They do the job, and they meet a sulfur cap. However, remember that we said people were becoming cost conscious. Well, synthetic esters, or we should say fully synthetic esters, are the most expensive option out there. And, cut cents and hundreds of a cent, that matters to these people. So because these synthetics, which at one time people thought that these synthetics were going to become the dominant ones in the marketplace, but as we've moved towards today, a lot of places that used to be using these synthetic lubricity agents, they're starting to move away from them because first of all, they're too expensive. And what they have found is that the old fears with the monoacids, the old fears about, lubricating oil interactions out in the field and, cold weather deposit formation, the people who made the synthetic lubricity agents who hammered on these points and created the fear in the market that you shouldn't use the monoacid because you're going to have these problems. What the users found was, it was a big meh. They said, well, we really haven't seen these issues, and so if it's going to perform as well and it's not going to cause these problems, and if it's going to be, a fraction of the cost, well, sign us up. And so that is basically what's been happening. So that leads to the question, if monoacids work just as well as the synthetics, well, why would anyone buy the synthetics? Well, here's a little secret. It's really an open secret because, you talk to a salesman from a major oil company, they can probably tell you this. These synthetics were developed by a company called Infinium. Infinium's well known in the marketplace. If you're in the industry, you know exactly who Infinium is. Infinium was a joint venture company that was created between two pretty big oil companies you may have heard of, Exxon and Texaco. So they created these synthetic esters. They work very well, but they are a lot more expensive than the monoacids are. So, again, the title question, why would anyone buy them if they're more expensive? Well, the reason is because anyone who's affiliated with Exxon and Texaco basically says, hey, if you're using our fuel, you must use synthetic lubricity. It's a captive audience. And so Exxon and Texaco have been able to to create their own market and to preserve it simply by requiring people who use their fuel and distribute their fuel to use their own product. So that's why synthetic lubricity agents, fully synthetic ester lubricity agents, that's why those still have a market. Now, how do lubricity improvers work? This is a basic diagram, and what you have here is you have the oil, you have the water, you have an oil film, you have an oil-soluble group, you have a polar group, and then you have the metal surface. So this is the lubricity molecule. This oil is the diesel fuel oil. But basically what you've got is, to put it simply, lubricity agents work by forming a boundary lubrication film on the metal surfaces. Here, from here to here, that's a boundary lubrication film, so to speak. And it protects the metal surface here. And so when that metal surface rubs against another metal surface, the lubricity agent is providing that lubrication, that needed lubrication and protection. Now, engine manufacturer, EMA is the Engine Manufacturers Association. And as you can see from the caption, it says some groups had, it's important, HAD, had not included lubricity in the definition of premium diesel fuel because they didn't think they could accurately measure the problem. Well, that was a long time ago. That was 20, 30 years before the present time. Nowadays, we know how to measure lubricity. They measure lubricity with two main test methods. The ASTM D6078 is commonly known as the Bockel-Scuff test. It's SLBOCLE. Officially, it's known as the Scuffing Load Ball On Cylinder Lubricity Evaluator. And it for decades it was the standard. So you can we have a picture of this is a ball-on cylinder lubricity test. So this is the Bockel-Scuff machine, and basically they would take a metal part, they would submerge it in some kind of liquid that they were measuring the lubricity of, and then they would apply a load, and then they would see how much of a wear scar was produced. And the smaller the wear scar, the better that liquid, the better that it protected, and so the higher lubricity rating it would have. The problem that they tended to find was that the test, while it sounds good, didn't have the best reproducibility. So you could produce what you thought was an accurate test result, but then if you took exactly the same thing, the same liquid, did it exactly the same way, you might not get the same result. And so there were concerns about reproducibility of those results. Well, they improved upon that, and they made a new test, and they called it the 6079 test, and that is the HFRR, and that is the standard that's used today. HFRR stands for High Frequency Reciprocating Rig, and it operates under a similar principle, but a little bit different machine that's used. And it involves a bearing, and it's between two surfaces, and it's being lubricated by the test lubricant, and there's a scar that's formed after a controlled period of pressure, and they measure the scar. Smaller the scar, the better protection. Now, the requirements that have been settled is that they want the scar to be less than 520 microns. And so that's where the standard came from, 520 micron HFRR wear scar. Still not a perfect test, better than the Bockel-Scuff test. What they found is it improved upon the reproducibility issue, which is good, but they still found it didn't 100% good indicator of field performance. And so that's why, for things like this, the groups like the ASTM and the Engine Manufacturers Association, they are rarely just sitting on their laurels saying, hey, we've done the best that we can. So you can bet that they are still looking right now at ways to make these kinds of tests even better from a predictive and a reproducibility standpoint. And there are other groups that weighed in. CARB, the California Air Resource Board. Well, they've been saying we need a basic standard since 2004. That was a full 2 years before ultra-low sulfur diesel even came into vogue. They always advocated that a 520 wear scar was what they needed. But what CARB tends to do is try and stay ahead of the curve on things like this. And so CARB has stated for a long time that they wanted to reduce it to have it even better, down to a 450 micron. Now, ASTM has to satisfy a lot of different actors in the arena, so they weren't going to fall directly in line with CARB. What ASTM did was they said, okay, we'll settle on 520, and so that was the standard. So why that matters is they wrote the wear scar measurement into the D975 diesel fuel specification. And what that means is that diesel fuel, or something that you're calling diesel fuel, must meet that standard and every other specification that's in that packet, the D975 group, in order to legally be defined as diesel fuel. So you could have something that comes out of the pump that looks like diesel fuel and smells like diesel fuel and is seems to meet everything else, but yet if you were to test it on an HFRR machine, maybe it comes out at 600. Legally, they'd say that's not diesel fuel, which kind of seems a bit weird, doesn't it? But it's, these specifications are there for the protection of the users out in the field. So that's the background on lubricity and lubricity improvers. So what we want to do in the last time that we have here is we want to talk about some solutions that Bel Performance has to give customers some options to avoid these problems. Bel Performance has a lubricity additive treatment for diesel fuel called Lube Pro. Now, it's an aftermarket lubricity treatment usually used by fleets and small volume fuel storage professionals. We also have a more concentrated version of it called Lube Pro RB, which is generally around, I believe it's a 1 to 5,000. It's just a higher concentration. It's the same chemistry as Lube Pro, but RB stands for refinery blend, and it is formulated for larger volume bulk treatments. Both of them use synthetic monoacid chemistries, so they're not as expensive as the fully synthetic ones. They don't have all of the overt problems that the dimer acids and the other esters had. The basic characteristics of it is fully synthetic, is a monoacid ester-based chemistry, and it was developed, remember going through the history, it was specially developed for use in ULSD applications, and by that it means it contributes a minimum amount of sulfur, so you don't have to worry about that. It doesn't interact with other additives and other, things that may tend to be found in fuel, so it's not going to cause any problems. So it can be used with confidence as a standalone additive for somebody who needs to improve their lubricity of their diesel fuel. The chemistry of it has pipeline approvals, and it also contains a little bit of what we call conductivity improver. Conductivity improver is an essential thing in the marketplace because diesel fuel, well, any kind of fuel, as it's being moved through a pipeline, tends to build up static electricity. And so you can imagine if it reaches a point where there's too much static built up and somebody goes to try and use it or to transfer it, there's a very, very real possibility of that static detonating the fuel. So it is standard operating procedure that there's conductivity improver added to diesel fuel at the bulk level, and that helps dissipate. It improves the conductivity of the fuel such that the static electricity charge dissipates and does not build up to a dangerous level. Lube Pro contains some of that. That's not going to be really something that the end user is going to worry about very much, but if there's a bulk treatment situation, that would be something that a fuel handler might be concerned about. All right, so that is the discussion of lubricity improvers and lubricity improver treatments for diesel fuel. Hope that this was useful to you, and if you have questions about this, you can email them to me at Bel Performance. The email is on the slide, ebjornstad@belperformance.net. Just send me an email and reference that you were watching the Lubricity Improver training presentation and that there was something that you'd like to know, and I'll do my best to get back to you and answer all your questions. So thanks very much for joining me. I am Eric Bjornstad, Technical Information Director for Bel Performance. And so thanks for joining me, and have a great day. Bye-bye.